Hello. Hi, Shivani. Am I audible? Okay. 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 I think I'll get started because it is already 6:02. Like last class, I think today also we'll be solving four questions. Questions are kind of easy. Just unmute yourself and ask me any doubts you have along the way. Okay. So now this is Gate 2015, question number 18 in set one, right? So here, what they're asking us to do is to find the LU decomposition of the given 2 cross 2 matrix. Now, you must be knowing what LU decomposition is already, because we have been seeing system of linear equations. Then from there, we came to row reduced echelon form. Now, from row reduced echelon form, you can find the you, so basically the row reduced echelon form will give you the lower triangular matrix, right? And here one hint they are giving the question is diagonal elements of u are both one, right? When they say diagonal elements of u are both one, actually before even going, are you familiar with LU decomposition, or should I cover that? Should I cover LU decomposition, or are you guys familiar with that already? Shion, if you're talking something, I'm not able to hear you. Okay, I want to cover LU decomposition. Okay. So then let's take this 2 cross 2 example only, and from this we'll see this thing. Now, to make the class interactive, can you tell me the steps? So the precursor to LU decomposition is finding row reduced echelon form. I think that you must be already familiar with, right? So now let's assume this to be the matrix A. Okay, as usual, my pen is not writing. Okay, yeah, my pen is not writing as usual. Okay. Oh, I don't know why my pen is not writing. Close this and open again. Just give me 2 minutes. I'll just fix this and oh no. Now what shall I do? It's not closing also. Ah, there should be application somewhere, right? How can I force quit this? Yeah, task manager. Okay. So now I'll open it again. Okay. Hopefully things should work now. Um, Pen is again not working. What's happening? I'm extremely sorry. I think my system is again kind of not very cooperative. Okay. Yeah, actually, let me open some other writing device. This is not working. Yeah. Okay. So I'll write in some other software, maybe not PowerPoint, and let me see what I can write. Maybe I can write it in Drop. Okay, this is writing. Right. I'll use this. Okay. That is PowerPoint. Yeah. So basically, you got the question right. So basically, you are given a 2 cross 2 matrix, and they're asking you to find the L22 of the lower triangular matrix, and further they are telling that diagonal elements of your one, right? So now let me note the given matrix 2249, right? So let's assume we are given a matrix A equals 2249, and for this matrix you need to find LU decomposition. And in last class we saw what is a lower triangular matrix, right? Basically, we saw how to convert A to RREF, that is low reduced echelon form, and we also saw that low reduced echelon form is a lower triangular matrix, right? So you know that you know the formula, you know the structure of lower triangular matrix. So basically, diagonal element should be one, and off diagonal element should be zero, right? And we saw that diagonal elements can be either one or zero, not necessarily one. And it turns out that for LU decomposition, okay, before even going to LU decomposition, I think I made a mistake here. Oh no, no, yeah, lower reduced echelon form we saw upper triangular matrix, not lower triangular matrix, right? Maybe I'll write things from scratch, but let me confirm if people are there. Okay, Shivani is here. Good. Okay. So Shivani, please feel free to ask any doubt along the way. Okay. So last class we saw row reduced echelon form, right? We saw that RREF forms at upper triangular matrix. What is upper triangular matrix? Basically, given a rectangular matrix or square matrix or whatever, first what you will do is to draw a leading diagonal, and you will try to make the leading elements on the leading diagonal equal to 1, and all the elements below the leading diagonal should be equal to 0. If it turns out that some entry of the leading diagonal cannot be made 1, you will make it 0, right? First you will try to make entry 1. If it is not possible, only you will make it as 0, right? This is what we saw for RREF. Now it turns out that LU decomposition and row reduced echelon form are both highly related, right? So in RREF you converted into upper triangular matrix, and you had a constraint that leading diagonal element should be 1 or 0. Now it turns out that any square matrix A can be written as product of two matrices L and U, right? And what is the structure of L? L should be it is the opposite of U matrix, right? Basically, all the entries below the leading diagonal should be non-zero, and all the entries above the leading diagonal should be zero, right? And U is we already saw in U. You will draw it is a square matrix because it's a square matrix. The leading diagonal goes from one corner to the other corner, right? This is L matrix, and in U matrix you will have entries above the leading diagonal to be non-zero and below the leading diagonal to be all zeros, right? Now in LU decomposition, one other constraint is either this leading diagonal, either this leading diagonal, either this leading diagonal or this leading diagonal should be all one. That's a constraint. Fine. So um, you can definitely have lower and upper triangular matrices, and you can choose which diagonal you want to have elements that are not equal to 1 or 0. But at least one of these two diagonals will be all ones, right? Now let us go to the question. In the question, they have told that all the elements on the leading diagonal of U matrix are 1. This means that this means that so they in the question they have chosen this diagonal to be all ones, which means that this diagonal can be any arbitrary number. This is not necessarily this necessarily need not be equal to 1. It can be any other real number also, right? Now, for this question, you can go through a complicated route of finding LU decomposition using rho RREF, etc., etc. But because it's just a 2 cross 2 matrix, we have a shortcut solution. Let's see how the solution is. Right? You are given a matrix A. A is 2, 2, 4, 9, 2, 2, 4, 9, and this A can be represented as product of lower and upper triangular matrix. Let's call this as L and this as U. Right? Now in this, if I draw the leading diagonal, basically it will be here, and we are given in the question that upper triangular matrix has all the entries on the leading diagonal equal to 1. This entry is already given, and for upper triangular matrix, you know that the elements below the leading diagonal are 0. Similarly, for lower triangular matrix, elements above leading diagonal is equal to 0. Right? Then what are the unknowns? Unknowns are, here you have U12, here you have L11, L22, and here you have L21. Right? Basically, these we have four unknowns in the matrices. Right? And then what are they asking? They are asking the value of L2. They are asking the value of this entry. Right? Now let's see how to solve this question. Now, so basically, what I will do, basically, if you multiply these 2 cross 2 matrices, what will happen? So this entry will be L11. This is here what I'm doing. Let's this L and this is U. I'm multiplying L and U. When you multiply L and U, the first element will be L11. The second element will be L21. This element will be L11 into U12, and this element will be let me erase this. So this will be L11 U12, and this element will be L21 U12 plus L2, right? And our task is to find out the value of L2. Right? Now it is very straightforward. So now you know L11 equals 2, L21 equals 4, right? And you know L11 into U12 equals 2, which means U12 will be equal to 1. Then at last we'll substitute L21. L21 is 4, U12 is 1, and L22 is unknown. So basically 4 into 4 plus L22 should be equal to 9, which means L22 will be equal to 5. Is the solution clear? Yeah. I'll just verify if the solution is correct. So by the way, you know this book, right? Gate Overflow book. If you don't know, and if you're preparing for Gate, this is a must-have resource, I would say. Yeah. Which year question was this? This is Gate 2015. Where do I see the answer? Matrices. Actually, I should have bookmarked the page number. Sorry about it. I'll just. This is probability. We don't want probability. Determinant of matrices. 4, 97, 98. Sorry, Shoni. I think I'll just take 2 minutes in finding the solution and then we'll move on to the next question. Sorry for wasting your time. Yes, 5. You got a solution, right? It is matching. All right. Is it okay? Shall I move on to next question? Hello. Yeah, I'll move on to next question. Yeah, this is a very easy question. Perhaps you should be able to answer based on what all we have covered so far. Can you take 2 minutes in answering this question? Okay, maybe I'll help you answer the question. So let me copy over the matrix 3, 7, 13, 4, 9, 2. Sorry, where is, yeah, 3, 7, 13, 4, 9, 2, and 45, 105, 195. 45, 105, 195. Right? Now they're asking us to do two operations. One is adding third row to second row and third column from the third column from the first column. Right? What are the operations they're telling? R1 equals R1 plus R3, right? And okay, add third row to second row, sorry. It will be R2 equals R2 plus R3. Then C1 equals C1 minus C3. C1 equals C1 minus C3. Now you tell me, okay, and the question is they are asking to find the determinant of the matrix, right? Determinant of the matrix after you perform these elementary row operations. Now let's say this is A, right? After performing operations, let's say you get A prime, right? In A prime, what you will do is you will take A, you will take the second row, and you will add third row to it. Right? A prime is such that second row in A prime is equal to second row of A plus third row of A, and first column of A prime is equal to first column of A minus third column of A. Right? Now, in last class we saw some properties. Right? If you perform linear combination, will the determinant get affected? No, right? So basically, this operation will not affect your value of determinant. Similarly, C1 equals C1 minus C3. This is also elementary row operation applied to columns. Right? This will also not affect the value of determinant. Right? Basically, then from these two operations, we know that determinant of A equals determinant of A prime. Now, for this question, I'll suggest you an operation. Right? Let us add one more operation. Let's say C1 or C3 equals C3 minus 15 times C1. What will happen when you do this operation? Basically, 45 minus 15 times 3 will be 45, so this entry will become 0. Similarly, 105 minus 15 times 7, this will also be equal to 0, and this will also be equal to 0. Right? And also remember that this is also elementary row operation only, which means this operation will also not affect the value of determinant. And we saw that while performing elementary row operations, anytime you encounter a row or a column that is all zeros, basically determinant of that matrix is 0. right? And that is why this question is very simple. uh, by doing just one column operation, you found out that you can attain all zero column, right? And the operations suggested in the question are elementary operations, in particular linear combinations, and we know that linear combination does not affect the value of determinant. That is why the value of a that you obtain, sorry, value of a prime that you obtain that you obtain after applying these two operations will induce a determinant value of 0. That is why answer to this question is 0. This is a tricky question in the sense, if you start solving this question by applying these operations and finding out the determinant using the normal conventional way, you will waste a lot of time. You have to make use of the properties. Is there any question in this solution? Good. So I'll go to next question then. So this is GATE 2015 set 3 question, question number 33. Okay. So here they have given us system of linear equations, and they're asking us to find which of these conditions is necessary for the system to have a non-trivial solution. Right. Now let us solve this question. So we have px plus qy plus rz equals 0. Q pqr qrp rpq. Achha. So I'll copy the question here. So px plus qy plus rz equals 0. Then next is rpq, is it? Okay. qrp rpq. Yeah. Okay. Trivial solution means, so okay. So here this is homogeneous system. What do you mean by homogeneous system? RHS of all the equation is equal to 0. There is no constant, right? There is no constant term here. In the if you remember from the previous class, we saw that a constant is a value that has a variable that raised to the power 0. We don't have any such term here, right? Now it turns out for homogeneous system, it does not matter what terms you have on the left hand side. If you substitute x equals y equals z equals 0, that is always a valid solution. Are you convinced? If constant is all if all the constants are 0, I can substitute 0 to all the variables and satisfy the equations. Are you convinced? Does that make sense? So what I'm saying is, to this equation substitute x equals 0, y equals 0 and z equals 0. So I'm telling the solution without even solving the system, because I observed that all the constants are 0. I can trivially substitute x equals y equals z equals 0. That is why it is called trivial solution. And for homogeneous system, if you have a non-zero solution, that is called a non-trivial solution. Yeah. So now they are asking a condition under which this system will have a non-trivial solution, right? Now let us solve this question. So you have PQ, PX plus QI plus RZ equals 0. Then QRP, QX plus RY plus PZ equals 0. Then RPQ, RX plus PY plus QZ equals 0. And in last class we saw one condition, right? For a system to have uh, a, a unique solution, basically determinant of a should be not equal to 0, right? This is when the system will have unique solution, right? And just now we discussed that any homogeneous system, by homogeneous I mean if all the constants on the in the equation are 0, then such a system is called homogeneous system. Now, for homogeneous system, x equals y equals z equals 0. This is always a solution. Now, if you link these two conditions, that is determinant of A not equal to 0 means unique solution, and know that for homogeneous system, 0 is a trivial solution. These two conditions imply that if determinant of A equals 0, then system has, sorry, determinant of A not equal to 0, then system has only trivial solution. This means to answer the question, that is they are asking condition under which they are asking a condition under which system has non-trivial solution. Then for the system to have non-trivial solution, you definitely need determinant of A equals 0. Right? Now let us solve this question. Now let me form the determinant A. So you know how to form the determinant A, right? So you will put the coefficients here. P, Q, R, Q, R, P, R, P, Q. Q, R, P, and R, P, Q. Right? Now if you find the determinant of this matrix, determinant of A will be equal to P into, so I'm taking my, I don't know what we call, do you call minus? I don't know. So the method I follow is I take a first entry and eliminate the first row and the first column, and I'll take it and I'll take the determinant of the submatrix. And determinant of submatrix is computing determinant of submatrix is very easy, right? So P into RQ minus P square, right? Then I'll do minus q into, so and when once I take this coefficient, I'll eliminate second column and second first row and second column. Then I'll get r into minus q into q square minus rt. Right? Similarly, I'll get plus r times qp minus r square. Right? Now let me expand this equation. So I'll get prq minus pq minus qq minus q sorry plus qrp plus RQP minus RQ. So let me club the Q, I mean these independent terms, I mean these terms together, right? If I club these terms together, what I will have? So basically I will have PQ minus of PQ plus QQ plus RQ plus 3 times PRQ. Correct? Now here you have to kind of know one formula. What is that formula? P plus Q plus R the whole cube. What is P plus Q plus R the whole cube? This is equal to PQ, sorry, this equals PQ plus Q cube plus R cube plus 3 into PQ square plus QR square plus RP square plus um, yeah, what else? Actually, I don't remember the formula for P plus Q plus. I mean this formula by heart. Let us refer the formula online. So A plus B plus C the whole cube. Yeah. So basically this is a formula, right? A cube plus B cube plus C cube plus 3AB into B plus C into C plus A. Okay. Sorry. Yeah. So let me make use of the formula. So basically P plus Q plus R. I'll erase this and yeah. So P plus Q plus R the whole cube will be equal to P cube plus Q cube plus R cube plus 3 into P plus Q into Q plus R into R plus P. Right? If I expand this further, what you will get? This will be equal to plus 3PQR plus, or let me expand to it, these two brackets first. So this will be equal to plus 3 times uh, PQ plus PER plus Q square plus RQ into R plus P. Now if I expand this equation again, then I'll get 3 times PQR plus P square Q plus PR square plus uh, P square R plus Q square R plus PQ square plus R square Q plus PQR. Again, I'm getting PQR. Yes, plus PQR. Hopefully, I have not made any mistake. I'll just verify once. PQ plus PR plus Q square plus QR into R plus P. Then you have PQR plus P square Q square. Okay, PR square plus P square R plus Q square R plus PQ square plus Q R square Q plus PQR. Yes. So then from this I can take yeah. So basically, so we have an expression, the determinant of A equals this quantity, right? Determinant of A equals this quantity, which means I can substitute. Let me take this quantity to the LHS. So then from this equation I have minus P minus of PQ plus QQ plus RQ. We need plus 3PRQ plus 3PQR. This will be equal to minus of P plus Q plus R the whole cube, right? And plus you'll have 9PRQ. I think you can take something common here. Let me see what we can take common. Um, so this term will definitely have P plus Q plus R the whole cube. Then can we do something from this equality only? Or I'm just wondering. Actually, yeah. So let us try from this inequality only. So I have this formula, right, for P plus Q plus R the whole cube. Now in the determinant I have. Uh, do I have more terms in determinant? I think just give me 1 second. I'll just figure out what's happening. So it will be P into RQ minus P square minus Q into Q square minus PR. Q square minus PR plus R into Q minus R square. Yeah. So from yeah, this is correct. So this is correct. Now from this and this is a plus. I mean this is a P plus Q plus R the whole cube formula. Now from this, if I were to take this quantity to the left hand side, then yeah, from this quantity, let me take this quantity to left hand side and bring this quantity right. Then what will happen? Minus of PQ plus QQ plus RQ. this will be equal to minus of p plus q plus r the whole cube plus 3 times you will have this thing p plus q plus r into r plus p, right? Now determinant is equal to plus 3. To find the determinant, we need this plus 3pqr. So what I'll do, I'll add plus 3pqr on both LHS and RHS, right? Or rather I can write 3 common, I can take 3 common and I can write this thing as p plus q into q plus r into r plus p plus pqr. Now we want the determinant equal to 0, right? Now let's see if there is any condition that satisfies determinant equal to 0. Now let us take the first inequality. Actually, if you see here, I have this term p plus q plus r, right? Let us search an option that assigns p plus q plus r equals 0, right? Then you can see here, like option C, basically they are telling p plus q plus r equal to 0. When p plus q plus r equals 0, basically this quantity will vanish away. This quantity will vanish away. Then we need to make use of the second condition, that is p equals q equals r. Now what will happen when p q r are equal? So basically you will have something is not adding up. When p q r are equal, then this will be equal to um, 2p into 2p into 2p, that is 8p cube. This will be equal to p cube. Yeah, actually I think I'm stuck in this question. I will take this question for the next class. Okay, I'll go to the solution and I'll come prepared with the solution to this in the next class. I think I'm doing some computational mistake somewhere. It will take some time. I have to sit alone and work out the solution. This will take in the next class. Is that okay? Is it okay if I continue with this question in the next class? Oh, sure, sure. Yeah. The procedure is same. So what you have to do is to find out which of these conditions will make the determinant of this matrix equal 0. Yeah. Or maybe if the time permits, we'll again revisit this question. This next time I'll solve it carefully. I'm making some silly mistake somewhere. So, in the interest of time, I'll go to this question. We'll perhaps revisit the same question again. So this is GATE 2020, question number 27. So here, what they have done is they have given us two matrices, A and B. They are square matrices, n cross n, right? And then this question is on rank, right? Now they are telling rank of m and rank of n. Okay, this question is about rank of m and determinant of m, right? They are asking which of the following statements are true. Can you answer which of these statements are correct? Okay, so is the first statement correct? Is rank of AB equals rank of A into rank of B? Is the first statement correct? Any idea, or do you want me to solve it? Okay, I'll solve it. Now let me convince you that this statement is wrong by taking a trivial simple example. Let us consider A equals B equals I. B equals identity matrix. We know that rank of identity matrix equals 3, right? Now then, rank, now you also we know that A into B is again I, right? When you multiply identity with itself, you will get identity itself. Thus, rank of AB equals 3 again, but rank of A into rank of B equals 9, right? And 3 is not equal to 9. That is why first statement is wrong. Is the argument clear? Okay, I think it is clear. Then second is a property actually. Rank or determinant of AB actually equals determinant of A into determinant of B. So second statement is true. The moment you identify a true statement, uh, you can basically eliminate the options, right? So either now your answer lies in either A or C. Or wait, is determinant of AB equals determinant of A into determinant of B? Let me just think over it. Um, yes, actually statement 2 is correct. Determinant of AB will be equal to determinant of A into determinant of B. Now let us take the third statement. Is rank of A plus B less than equal to rank of A plus rank of B? Is it true? Yeah, actually that is true. So I think the answer to this question is 2 and 3. 2 and 3 only, right? Because when you sum two matrices, its rank cannot exceed the ranks of individual matrices. Okay. Now, nonetheless, let me verify this solution. So, answer is right. Answer is C. Is it okay? Are there any doubts in the last question? Okay. So then I'll assume that last question is correct. Now we have 15 more minutes. In 15 more in these 15 minutes, let me try the solution to the other question where we were stuck. So this time, let me know the correct formula for A plus B plus 0 whole cube, and then we'll solve it using that. A plus B plus C into A B plus C plus C minus. Okay. I think this formula looks correct. Let's make use of this formula. So I'll take the matrix. Shivani, you can also solve it, independently. Let's see if you are able to hit an answer. Okay. I'll also solve the question. We have the matrix A, P, Q, R with coefficients P, Q, R. Then we have QRP, RPQ. Q, R, P, and R, P, Q. That is the matrix A. Now we need to find determinant of A. we need to find condition that will give us determinant of A equals 0, because this is when you will have a non-trivial solution for homogeneous system, right? Now determinant of A will be equal to P R Q. Let me correct notation. So it will be P into RQ minus P square minus Q into Q square minus PR plus R into QP minus R square. Now this, if I expand, I'll get minus PQ plus PQR minus QQ plus PQR minus, sorry, plus PQR minus RQ. Just 1 minute. Yeah, minus RQ. So this I can club it as minus of PQ plus QQ plus RQ plus 3PQR. Now this is what I get for determinant of A, right? I need condition so that determinant of A equals 0. Now with this, I cannot obtain. With this, I cannot apply any of the following, any of these options, right? With this, I cannot apply any of these options. So that is why I need to further simplify this equation. I need to simplify this equation. Now, one hint you can get is, because degree of each term in this RHS is equal to 3, let us substitute, I mean, let us replace this RHS with formula for P plus Q plus R the whole cube, right? What is P plus Q plus R the whole cube? P plus Q plus R the whole cube will be equal to P cube plus P cube plus Q cube plus R cube plus other terms are 3 into A plus B plus C, AB, AC, BC minus ABC. And 3 is outside, right? Plus 3 into A plus B plus C into AB plus BC plus AC minus 3 times ABC, right? Sorry, minus ABC. This is a formula for P plus Q plus R the whole cube. Now, what we have here, we have, let me take the term, let me take this term, P plus Q plus R the whole cube and ABC to the left hand side. Once I take this term to the left hand side, I'll get minus of P cube plus Q cube plus R cube, right? And minus 3ABC will become plus, sorry, this, I'm sorry. So here P A is P, B is Q and C is R. So this will be PQ, QR, PR, PQR. Okay. So plus 3 times PQR will be equal to minus of P plus Q plus R the whole cube plus 3 times P plus Q plus R into PQ plus QR plus PR, right? I think this is okay so far. Now let us look at the options. Now we need to find out which option gives us determinant of this A equals 0, right? Now for me, the option that is catchy to my eye is option C, where they say P plus Q plus R equals 0, right? When P plus Q plus R equals 0, what will happen? This term will be equal to 0. Let me shade it. So this term will be equal to 0. This term will be equal to 0 because P plus Q plus R equals 0. And in the other term, again this term is equal to 0, right? And product of this term and this term will be equal to 0. That is why determinant of A is equal to 0, right? The first part of option 3 is correct. Now let's apply the second half, where they say P equals Q equals R. When P equals Q equals R, I can substitute Q equals P and R equals P. And when I do that, what will happen? So this will become minus of, let's say, 3P the whole cube plus 3 times P plus Q plus R will be 3P into PQ plus QR plus this thing will be 6 times P, right? What I'm doing, because P equals Q equals R, I'm substituting Q equals P and R equals P, right? Now if I now when I expand this, this will become minus 27 PQ plus 3 plus 6 is 9. This will become 9P, and 3 into 9P will be 27 PQ. There is some mistake again, is it? Yeah, yeah, yeah. So this will be 3P into 6P square, right? Because I have when I substitute PQ equals P, that basically this will become P square. This will also become P square. This will also become P square. Then I will not get. Yeah, I think there is again some mistake. What is the mistake? No, no, this is correct. Yeah, this is correct. Um, so basically here what you will get is here you will get 3 into 3P into 3P square, right? Which is again equal to 27 PQ, right? Basically this quantity and this quantity will subtract and you will get 0. That is why option 3 is correct. Sorry, option 3 is correct. Either under the two cases, that is when P plus Q plus R equals 0, the determinant of this matrix will become 0, or when P equals Q equals R, the determinant of this matrix will also become 0. Okay, is it okay? Was the solution clear now? Yeah. Okay, then if you have any doubts, we'll take it up. Otherwise, we'll end the session. Okay. Yeah. Thank you. Thank you so much. Bye.